Okay, so this is HESI Chemistry video number 2. We're still talking about elements and atoms and subatomic particles. So here we have our model of the atom again with our protons, neutrons, and electrons. So a quick review. The things you need to know about each of those are that the protons have a mass of 1, charge of +1, and they live in the nucleus right here. Neutrons, mass of 1, charge of 0, and also live in the nucleus. So they both have a mass of 1. They're represented by circles of about the same size. Electrons are teeny tiny. They have a mass of essentially 0. We consider it to be 0 when we're talking about the mass. They have a charge of -1, so it's the opposite charge of protons. And they live outside of the nucleus in these areas that are sometimes known as electron clouds, shells, or orbitals. So be familiar with all three of those terminologies. So first thing I want to talk about today is the atomic number. And this is the world's easiest equation because the atomic number is equal to the number of protons. There's no math at all. If you know how many protons there are, you know the atomic number. The other interesting thing about the atomic number that you definitely need to know is that the atomic number is the identity of the atom. What do I mean by that? How many protons are in there dictates what element we have. So I'm going to swap over to the periodic table. And the atomic number is always a whole number because we can only have a whole number of protons. You can't have 1.5 protons. And it's the number, it's in different places on different periodic tables here. It's this number 1. And as you go across the elements, the atomic number just increases by 1 for each element, which means we're adding 1 more proton. So hydrogen has 1 proton. The atomic number is therefore 1. And if it has 1 proton, if any atom that has 1 proton has to be hydrogen. That's how it's defined. Helium has 2 protons, so every single atom of helium that there ever has been or ever will be has 2 protons because that's what makes it helium. And so on with lithium, atomic number of 3 protons, beryllium 4, and then we skip over here to 5 with boron, 6 with carbon, etc. So back to our example here. If we have 5 protons, 6 neutrons, and 2 electrons, what is the atomic number? Of course, it's 5 because we said the atomic number is equal to the number of protons. And so here it's depicted. We've got our 1, 2, 3, 4, 5 protons, our 6 neutrons, and our 2 electrons. But if we're told how many protons there are and all the question is asking you for is the atomic number, then you can completely ignore, it does not matter how many neutrons or electrons are in there. Only the number of protons gives you the atomic number. And so if there are 5 protons and the atomic number is 5, then our model here is a model of 1 atom of boron.